Forensic science is the application of scientific methods and principles with the goal of supporting legal decisions in criminal or civil law matters. Forensics has various fields of specialization, such as psychology, biology, chemistry, general sciences, anthropology, computer sciences, and many more. Here in Canada, most forensic tasks are done by forensic identification teams from various law enforcement departments, although some specialties are covered by outside experts that are contracted by the law enforcement departments to complete investigations. The experts that are contracted by the law enforcement teams are often experts in a related field, such as pathology, odontology, anthropology, entomology, and many more, and often use their expertise in these other fields to assist the investigations. The forensic identification teams are mainly focused on the applied sciences side of forensics, and most often collect evidence from crime scenes such as fingerprints, DNA samples, tire tracks, foot and or shoe prints, blood spatter analysis, ballistics, and anything else that could be considered physical evidence in a crime scene investigation. These teams use various techniques and practices and technologies to pull key information from even the smallest pieces of evidence, or even collect evidence that is invisible to the human eye. Fingerprint collection and analysis are done with the end goal of identifying a person of interest, also known as a suspect's implication at a crime scene. Fingerprints are collected and analyzed and compared against fingerprints of known persons to determine if they are a match. The first step to fingerprint collection is to find and identify the presence of fingerprints. There are 3 types of fingerprints that can be found at a crime scene. The first is a print on a soft surface, such as wax, wet paint, soap, or other surfaces of that sort. And the fingerprints found on these surfaces are most likely to be 3-dimensional or textured. The other type of prints are found on hard surfaces, and they are either latent, which means invisible, or patent, which means visible. The latent prints are left by oils and sweat produced by your skin and transfer onto the other surfaces. These prints are not readily visible, therefore detection of them will often require the use of specialized equipment and products such as alternate light sources, chemical agents, or fingerprint powders. The patent prints are created by other substances that were on your finger and transferred onto the surface. An example of this type of print would be having ink on your finger and then touching a wall, table, paper, etc. The print would be left behind on that surface and readily visible to the eye because of the ink. The second step is to collect the prints. The collection of patent prints is the simplest and most straightforward method: photography. Since the print is visible to the eye, all that is needed to collect proof of its existence is a photo. The pictures are taken in high resolution with a forensic measurement scale in the frame for reference. Extra techniques can be used in photographing of the prints, however, these are not usually necessary. The collection of latent fingerprints is more complicated than that of patent fingerprints. The most common method is to identify and collect latent fingerprints is dusting a surface with fingerprint powder, which is a dark powder. If this powder identifies any prints, they are then photographed, then lifted from the surface using clear adhesive tape and placed on lift cards to preserve the print. Another method for latent prints is alternate light sources, or ALS. The alternate light sources are LED or laser devices that emit specific wavelengths of light. These prints identified by the light can then be photographed or enhanced by powders, dyes, or chemicals, then photographed. Another method is chemical developers. The chemical developer is often used on porous surfaces such as paper to identify an invisible print. The chemicals react with specific components of the latent print residue and give the print color, making it visible, to then be photographed and sent off to be analyzed and compared. The final step is the analysis. Once the prints are collected, they are sent out to the labs or the agencies that will be conducting the analysis. The analysis can be done either by a computerized system where images are submitted and it compares and identifies any matches or similarities between unknown and known prints, or by a professional who will do the comparison manually. These matches and similarities are then reviewed and confirmed by an examiner for a final decision. The fingerprint examination can be done by forensic scientists, technicians, or police officers who have received the right training and are certified by the right associations. Once the analysis and comparison are complete, the expert will decide if the print is consistent or inconsistent with a known fingerprint, or if it is inconclusive, meaning there was not enough information provided by the print to be certain of anything. Bloodstain pattern analysis is the reading of bloodstains found at a crime scene to be able to reconstruct the scene in the moments that created the bloodshed. The analyst examined many elements of stains such as size, shape, and distribution to form opinions about the possible actions that did or didn't happen at the scene. There are many different bloodstain patterns that can be found, such as pools, spatters, and microscopic droplets. The shape depends on the amount of force used to project the blood and the type of surface that it lands on. A drop of blood falling onto a smooth surface from a 90-degree angle will result in a near-perfect circle. A smooth surface will cause minimal distortion, but a rough or coarse surface will break apart the circular shape because the surface tension of the droplet will be disrupted. The amount, location, and volume of stains can also affect the amount of information gathered. A very large amount of blood can disguise important spatters, and too little blood is very difficult to gain information from. Bloodstains are collected for analysis by photographing, packaging stained items, cutting out sections of material such as carpet or curtains. Teams will frequently sample bloodstains to build DNA profiles. Samples are taken by soaking up pooled blood or swabbing dried spatters.
Hi, I'm gonna start. It's my turn now. So my part it's footwear and tire track analysis. So the basic theory behind footwear and tire track analysis is that shoes and tire may leave behind either prints or impression that can be examined by investigator. This print to impression can be compared to a suspect shoes or vehicle, yeah, to determine if the shoes or the tire is the same one at the left, the impression footwear. Footwear impression hold equal signification, whether it's a muddy footprint on the floor or shoes print left in the snow. Each tell a unique tale of class, individually and wear. Sorry, class characteristic stemming from the manufacturer proceed offer a glimpse into the make and model of the shoes, while individual characteristics speak of its unique journey, like a cut, a gouge, a twig stuck in the tree. Footwear and tire tracks can be found on various surfaces, from paper to human skin. Visual print left body on surface are easily discriminable. Plastic print, three-dimensional imprint on surface offer dangerous glimpse into the past. And then there are latent prints hidden from plain sight, waiting to be uncovered by a powder, chemicals, or alternative light source. This imprint impression can be compared to a suspect shoe or vehicle tire to determine if the shoe or the tire is the same one that left the impression. The physical feature change over time. This is called wear. The method of collection are as diverse as the impression themselves, from adhesive lifter to gluten sheet. Forensic examination employ a narrow of technique to recover the evidence intact. And I'm gonna make a picture so you can see what I'm talking about. And for three-dimensional impression, casting becomes the method of choice, creating detailed replica that's preserve every contour and detail. Suspect sample are meticulously analyzed, measured, and scrutinized along the crime scene sprint. Sorry. Divider, galloper, and special lightning aid examiner in their quest for truth, ensuring that no detail go unnoticed. In conclusion, forensic science is crucial for connecting science with law enforcement in Canada. Specialist team, along with outsider expert, handle various aspects like fingerprint, blood strain, and footwear analysis together. Understand and interpret evidence from crime scene. This method help reconstruct event, identify suspect, and provide crucial information for legal proceed. Forensic science, evolving with technology, remain pivotal in ensuring justice is served by bring, bringing the gaps between scientific investigation and legal proceed. Thanks for listening.